Hi, and welcome to So You Want to Be a Data Scientist. Today I have Madli with me. She used to be a colleague of mine before she left to go and follow her dreams on this new, exciting and thriving startup called Pactum in Estonia. But today she's going to tell us about her experience being a data scientist and what she did day to day and why she chose data scientist or being a data scientist in the first place. So welcome, Madli.
Hi.
So first I want to ask you why you chose data science.
So I have always been the kind of a person who really likes to do a lot of different kinds of things. So actually when I graduated my high school, then I thought that programming, I didn't know exactly what I wanted to do, but I thought that programming is like the least likely thing that I would ever do in my life.
Yeah.
So I first did my bachelor's in law, and then I did a bachelor's in psychology. And after that, I started getting really interested in data science. And the reason why I started liking data science so much is because you have the possibility to see into so many different worlds, because data science isn't like, it's kind of offers you the tools that you can use in various different areas. And that's what I really enjoyed about it, and that's what motivated me.
So you kind of wanted to work on different areas and not strictly in one area.
Yeah, that was one. And then also secondly, for me, it has also been really important to make decisions based on something factual instead of just based on your gut feeling. And like when I was studying law, then I could see that when I was working in the Ministry of Justice in Estonia, then I could see that sometimes you just wouldn't have any sort of validation on whether you should pass a law or not. And I really missed having this kind of like quantitative information to know like if we pass this kind of a law, then we can see this kind of a change in the society. And also in psychology, of course, like I had done some data analysis there as well before.
Yeah.
And it became really apparent how sometimes people can be fooled with bad statistics and bad evidence and bad science. So for example, with things like homeopathy, or you understand how there are so many different psychological triggers that can make people believe a certain thing, but then actually there's no scientific evidence.
Yeah. When you look at the data, it's actually not even like enough number of people to say significantly that this is the outcome.
Yeah, exactly. Like you have a difference between two groups, but the difference isn't actually statistically significant. So because of all of these experiences, I realized that data science offers me this tool that I could use in almost any area to fix these kinds of problems and to help people make really better decisions.
Yeah, it's kind of like a superpower in that sense. Like, you know, if you have you need to have proper data, but then after you have the proper data, you can you have this tool and this power to understand what can go wrong and how can you fix it and how can you actually come to healthy solutions and results. That's cool. So how did you study for data science?
So I studied to be a data science at the University of Amsterdam. So I was doing a data science master's there. And before I started studying that, I had studied programming a bit on my own. However, it was still quite difficult for me to do the master's there because like the majority of the people who also studied data science, they had more experience in programming before than I had. So that time was pretty intense for me. But yeah, I think it gave me a pretty solid understanding of the different areas in data science. So you would have courses in, say, in general, like data science projects, visualization, then machine learning, then even like business and data science, these kinds of things.
So, but then I think you already said it, but just to like reiterate, your background was in law and psychology before you started data science. So you didn't do any programming, or you didn't study computer science, or
I had just
technical.
Learned programming on my own a bit.
Okay, which is totally possible, especially with Python, because it's a really simple programming language.
Yeah,
one of the easier ones at least.
Yeah, but I think for me it was also for me it was still difficult.
Of course.
If you there's kind of like, if you haven't done any programming before, I think the hardest part for me to get over was that I don't know, I just really always had the feeling like you need to be or I don't know, it just really frustrated me when your code is not running. And then I feel like learning how to program really changed in the way how I think in other things as well, because with programming you have to do little iterations at a time and then see what works, what doesn't work, and deal with failures very constantly. So I think has also made me better in dealing with failures maybe in other areas of life as well.
That's a nice way to look at it.
Because I really in the beginning I remember how frustrating it was. And you just need to get over it, and then eventually, like after I guess a half a year or a year, you will get to the point where it feels more comfortable to program, and you don't see it as like something that stops you from thinking. You know.
I kind of heard that from a couple other people when they never programmed before, and when they start for the first time, especially if it's only for data science, which is like programming is just a small part of it. It's not actually the whole thing that you're doing. It's just a small tool, and they say like, I just keep getting errors and I feel like I'm doing everything wrong, whereas actually programming is getting errors and fixing them. That's all you have to do. You just need to Google the like hell out of it, and that's all, you know. But when you're starting out, it's kind of frustrating if you feel like you're doing everything wrong, whereas actually you're doing it right. If you're getting proper errors, then like it looks like everything's fine, you know.
And it's sometimes really interesting also to see really professional coders, because you see the kind of things that they Google are still super basic sometimes.
Exactly.
Like how to go file by file in a folder or something like. It just, I guess, especially if you're eventually programming in several different languages, then you don't remember all of the specific commands.
Yeah, exactly.
And the trick is not to mind it, or just be okay with Googling things and then just doing whatever.
Yeah, exactly. It's impossible to always remember every little thing that you were gonna write. Like I wrote C++ maybe for like 5 years, and if I go back now, I'll probably need to like Google every single thing. So it's kind of not like programming. I always think of it that way. It's not really knowing everything that you have to write. It's just knowing what the structure is and then kind of going with it and kind of knowing what you have to learn to go the next step. So that's important for people who are starting newly. So you're not currently a data scientist, so you kind of took a little turn in your career. Can you tell us about that a little bit?
Yes, so I worked as a data scientist in IBM for almost 3 years, and I'm currently working as a product manager for a company called Pactum. And so Pactum does automatic negotiations. So my background in law and psychology I could also use in that company, but I think also as a product manager it's really nice to have a background in data science, because then you can have a very data-driven approach on how do you develop a product. So how do you collect users' feedback, when is something like, when do you have enough data points to say that something is should really be changed about the product. Like how with our product as well, it's really interesting to analyze the behavioral data of people. Like for example, especially in the negotiation situations, how does people's behavior change based on how you phrase things. Like
so you do testing for that too?
Yes.
Okay.
Yes. So for example, if you say you had the chance to earn X amount of money last month, or you missed out on X amount of money in the past month. Like, how does this change? Whether it changes people's behavior, and then make decisions based on how we're going to do the automatic negotiations in the future as well. So it's there are some data science is so broad, so that I feel like you could later on, if you want to continue on your career in say marketing, then you would also still benefit from data science. Or if you want to go to general management or whatever, then that's another cool thing about data science, is that you're not stuck in one very specific career path.
So you're still using your data science skills then?
Yes.
In your position. But do you still do, for example, hands-on practical analysis?
Yeah, exactly. Like with the data that we collect in the organization, with that, and then also like general programming sometimes, like when you need to help out something with a product, or understand the code that other people have written, for example, then that's also useful with my current job. And I guess also in the future, once you become like a manager of a couple of people, maybe if you have data scientists in your team, then it will be useful for you to know what exactly they're doing and understand how they come to the solutions that they come to. Yes.
Okay, so but I want to go back to your IBM years, the 2.5 or 3 years that you worked at IBM, to understand what you did there as a data scientist. Were you an in-house data scientist, a consultant, or a freelancer? How did it work?
So I was a consultant at IBM. And I really enjoyed it. I think that this is pretty much like the coolest way how you can start off your data science career is to be a consultant. Because the way how my career worked, at least, was that you get these projects that are usually like around 3 months long. And then during this time, you usually you go to another company and you figure out everything from the beginning to the end. Like, you understand what kind of data you have, what is the objective, and then how do you what do you need to do with the data in order to finally go to the objective. So for example, some projects that I was working on were predicting when ship motors are going to fail. Then also looking at, so I worked together with a telecom company, and we worked on everything from the beginning to the end to trying to figure out how they can commercialize the data that they have when it comes to like people's cell phone usage. So it was really interesting to think about like how do you do it how do you use people's movement data in an ethical way. Like for example, you could offer shopping centers insights into what kinds of people visit the shopping center by what times of the day.
Wow, is that even legal?
Yeah, so it was really in the beginning of the project actually there were a lot of legal concerns. But then eventually if you only take the data over like 100 people at a time or something, and then you use the aggregated data of people, then it's okay to use it because you're not really violating the rights of any single person. So it was kind of interesting to see that you get these groups of people who have very different behavior. So for example, people who travel all around the city all the time, or people who just go from their house to the office and back. And then based on that, you get these different kind of personality types. And then you could offer some insights into like what kinds of types of people go to a specific shopping center, for example. So then some other interesting projects that I had was we went to an office building and we set up sensors in the office building to monitor what is the CO2 level, the humidity level, the oxygen level, the noise levels in different places. And we asked people in the office to fill in forms on how they felt in different parts of the office. And we also used some scientific research on what makes a productive office work environment. And then eventually we made like a dashboard and some recommendations to the office building on how they can design their office so that people would feel better when working in that office. Or also I had another project that was about predicting whether a construction project is going to be successful or not.
Oh, that's interesting.
Then one with predicting how many earthquakes are going to happen in a certain amount of time. And then one where we were trying to build an autonomous endoscope. Yeah.
That one was interesting, definitely.
It was really, I really enjoyed it, that it was like so, all of these experiences, like I never thought that working with ships would be so interesting, or ship motors, or working with like very specific companies who make a very specific kind of a chip, for example, that these will be worlds that I otherwise would know nothing about. So that's why I think it's cool to be a consultant.
It is always interesting, right? Maybe you think that you will never be interested in stuff like that, but then once you start working in it, you kind of have to get some domain knowledge and understand what's actually happening there. And it turns out to be pretty fascinating. You know, there are a lot of details that you never would have thought about, and things that you have to learn and take into consideration while you're building your product. So that's a good list of projects, really interesting. So I want to ask more about how these projects were evolving. So for example, in the sensor project, for example, you said you went to the building and then you put the sensors and you collected the data. But I guess that's not a really traditional way of doing it. So in a traditional project, how does it work? Do you go to the client and they have a data set ready for you?
So usually how it went is that you go to the client, and then they usually have some sort of a vague sense of what kind of a problem they would like to solve and what kind of data they have. So you need to do some workshops to really distill, like, okay, what exactly are the problem areas that they're talking about, and be as specific as possible with these kinds of problem areas. And meanwhile, also kind of check, like, are we really going to be able to get the data about these kinds of problems from the client? And usually it turns out that
you can't.
Yes, that you have very I think the biggest bottleneck for organizations usually is that they don't have enough high quality data for the specific problems that they want to solve. So then it's kind of a combination of the two, like where do you have enough data and where the problem is important enough for you to solve it. So then you figure out what is a good combination. And usually when you then request the specific data, you still find out that there's a ton of problems with the data. Like there are some parts that are missing, some parts where people are not really sure on like whether this is accurate or not. Then you just have to combine multiple data sources. Sometimes it's difficult to combine them with each other. So requesting the data, also getting the data access and being like cleared for that in different organizations can also take a while.
So it's like a story of its own.
Yes.
Even before starting a project, just getting the data, making sure the data exists.
Yeah, I think even like really data engineering skills are definitely skills that are super important for a data scientist as well. And also, or alternatively, if you have a data science team, then it's always nice to have someone who's really good at data engineering, and then a data scientist who does like the analysis on top of it. So data engineering is, I think people are really looking for data scientists, but for data engineers, or like many companies are even more in need of a good data engineer than a data scientist.
Yeah, I think recently also there is this misunderstanding, at least that's what I've seen in the industry, that a data scientist is everything. There's a data engineer, ML engineer, data scientist, data analyst. So people kind of expect you to know everything and kind of know where to find the data, clean the data, analyze data, create a model, and then also maintain it after you put it in integrated it with the daily processes of whatever company you're working for. So it's kind of, I think, like a faulty line of thinking, because then you have these people who are the data engineers and they're doing something totally separate from data scientists. So we need to kind of make sure that people understand that these are two different things, and okay, there might be some overlap, but at the end they're really different and valuable skill sets.
Yeah, I agree. Yeah, but continuing on with how does the project then go? Then you finally get the data. Then the next step usually is that you visualize the data, so that that is very frequently also already beneficial for clients, because frequently they haven't had anyone who has really looked into like what has happened over time. And you can already sometimes visually see some interesting patterns. Like for example, when it comes to predicting whether construction projects are going to fail or not, already by visualizing the failure rates and certain categories, you can see like that some categories or some variables really influence whether a construction project is going to fail or not. Like for example, working with a specific partner when you do a construction project. So this kind of visualization step I think is really important, and you really shouldn't omit that. So then you visualize it, you start making the first hypotheses on where do you think the model would go, and then after that you start building the model and testing out different models, and it's important to also start with the easiest possible one and then gradually make it harder and harder.
Rather than putting on a deep learning algorithm away, right?
Yeah, I've definitely made that mistake several times, because I did my master's thesis in deep learning also. So when I did my master's thesis as well, then I didn't really properly understand everything about deep learning in that moment when I did it. And then I ran into some trouble having like really complicated models, and at the end realizing like, okay, I'm not like, don't really understand what my model is doing anymore. So I really need to start from scratch, because otherwise it loses control. We actually had this joke with my classmates that whenever someone's program was doing something that they didn't understand, then they were like, oh, we built AI because it became more intelligent than humans.
That's so fun. Nice. Okay, so a project for you looks like you go to the client, they have a vague idea of what they want to be achieved in that project. They kind of know if they have the data or not, but they're not really sure. So the first process is getting the data, probably going and talking to people on their side, trying to understand the data also after you get it.
Yes.
And then you try to visualize it. And then see the first insights that you get from it, and then you decide the rest of the project and how it should go. So how do you divide your time in these tasks? What do you think is the thing that takes the most time?
So the most time you usually, I think, spend on understanding the data. And like first cleaning it, and then secondly like talking to people, really getting a sense of like what does each specific term mean. So especially when it comes to a very niche area, then like I would say, like if you're working with, say, like sales data, it's something that's usually quite easily, you're able to understand it quite easily, because as a consumer you've been in a store and you know kind of how it works. But then if it comes to say machines that build microchips or something, then for me at least this was the kind of a world that I had no prior knowledge of. So sometimes you need to understand like specific specs on like their machine, like how does each individual machine part do. So that takes a lot of time frequently in these kinds of projects.
So you also kind of have to learn about this machine. So you can't just have someone tell you, oh yeah, this is about this little thing, but then you also need to know what that little thing does.
Yes.
And what its role is.
Yes, like because if you're eventually trying to predict whether a component is going to fail in the machine, you need to understand like what are all the possible ways that it is going to fail. So for that you need a bigger understanding.
Yeah.
So yeah, that's I think the most time consuming part. And also sometimes it depends on different clients and what they want. But I've had different kinds of clients. So there are some who are just interested in getting the most accurate possible model for their problem. And in that case, you also need to spend quite a lot of time fine-tuning the model and like trying to get it to be as good as possible. But then with some other clients, they're mostly using it to get it's more for like data communication, or like to get a better understanding on what their strategy should be, for example, in the company. And I think frequently people are really scared of getting into the details of these kinds of models. So with visualization and good user experience, you can enhance their experience so much more, so that they're not afraid to interact with data anymore. So in these kinds of projects, I would say that it's quite important also to be good in visualizing your results and communicating the results as well. Because this way, if you want to create people's behavioral change so that every day they would like make their decisions based on data, then I think that brings them a lot closer to this. If you have like nicely visualized data, that is also easy to use for business people who have no prior knowledge.
Yeah, I guess at that point it's really important to be able to empathize with those people and know how they understand things, because you might think that, oh, this is really simple, I'm just telling you, listen to me. But then at the same time, if you're not using the jargon that they're using, the words that they need to hear, then it might just be a lot of fluff for them. They might not understand what you're saying. So.
Yeah, I've even had that, like, for example, with one project, this kind of visualization part, I feel like frequently data scientists look over or like don't think is so important. But at least as a consultant, I've had several projects where, say, the client in the beginning has said like, yeah, we don't care, we really want a really good model, even if you run it on the command line, then that's completely fine. And then eventually they've still been super impressed by nice visualizations, and that has been one of the main points why they wanted to continue on with this project in the future.
Yeah.
So, or also some clients who've really said that just admitted that it's really important for them to have a nice visual experience with this, you know?
Yeah, I mean, we're visual beings, so you can just say a lot of stuff. You can have a PowerPoint presentation, but if you have a nice, concise visual at the end, then everyone understands what's going on way better. It's more clear. Great. So this is kind of your story of a project, but then at the end, what do you deliver to the client?
So it depends from these different kinds of use cases. Sometimes, for example, like if it comes to, if you're trying to predict whether you have a user who might be committing fraud, for example, then of course, in that case, it's important to get a model that is as good as possible. And you deliver this nice model that where you can work together with the development team to make sure that this model gets integrated to the actual product, like for example to the bank or something like that.
So it's kind of like a file then?
Yeah,
Okay.
you have like a model file that gets integrated. With some other projects, if it's more on how to make good business decisions, then the outcome can be, for example, so usually what I like to make was this website with interactive visualizations so that the client can go to different tabs on the website and explore different problems and kind of get a little story on how the problem, like what is the current situation with the problem, what they should be doing in order to fix it, and what do we think is the way forth with this.
So that's a more complex deliverable then?
Yeah. So it's in the sense, it requires just, I guess, different skills so that you know how to make these kinds of visualizations and stuff. So these things, I guess these are the two main deliverables that I've had in my projects. With some projects also, I guess some companies just want to have a general strategy on like how do they continue on doing data science, but that is more rare to ask consultants or data scientists to come up with these kinds of strategies. So I think usually it is either delivering a really like a model, or so it usually is either delivering a model or some visualizations to support decisions.
I see. What was the most boring project that you were a part of as a data scientist?
Good question. I need to think about it a little bit. I think, I had this one project where I was working together with quite a big team of data scientists, and I joined the project later on so that everyone had kind of already settled on what they're going to develop and do. So I ended up only like helping other people with their projects, but I didn't really have a very specific thing that I owned in the course of this project. So that was something that I didn't really enjoy that much.
I see. So like the lack of responsibility and the fact that you're feeling like you're not really helping that much, or
so these kinds of things.
Okay, that's totally valid. I think it doesn't always have to be the topic that you're working on is a little bit boring, but maybe it's just how you do work and how much of an impact you have on a certain project. It's really important.
Yeah, I think also like when it comes to the topic, then it was really cool to see how so when I was studying data science at university, then people had such different backgrounds, and it was so cool to see how they were able to take data science and then do something really cool in their own area with this. So we have people who had been studying physics and who were interested in doing data science on space, or like some people who had studied healthcare and were interested in trying to, for example, model new drugs or like have a creative approach on whether you could have new drugs that would cure specific diseases, for example. So for me it was also very cool to see all of these different areas, how people were thinking in data science, and how you don't really have a very classical like one single image of what a data scientist can be, but it can be like, you know, you take whatever you've learned before and then use it as a data scientist to your benefit.
Yeah, that is a great message also for our listeners who are aspiring data scientists. So my final question to you, and this is a different question. What is it like being a woman in data science?
I think usually I actually get more positive attention than negative attention for being a woman, because there are just so few women who are in technical areas. So it is easy to stand out, and I think usually that's a good thing because people pay more attention to your skills and what you have to say. However, sometimes I do think that women tend to have this like the way how they present themselves tends to be less confident than men. So like, for example, when I was just finishing the sentence, then I finished it with my intonation going up, suggesting like not being certain,
kind of a question-ish statement.
Yes, so women tend to do it a lot, and I think men tend to interpret that frequently as inexperience. Or at least this is what I've been told.
I think probably both men and women are interpreted as you coming across as less confident.
Yeah. But I think it's especially a big problem when you're the only person around who does these kinds of things. Yeah. So fortunately, I think at least it's something that people are becoming more and more aware of, and men also. I think, or at least the men that are around me, frequently try to pay more attention to like how do you interact with women? How do you make sure that they feel confident and comfortable in what they're saying? And for women, I think it's also sometimes they don't mean to be uncertain in what they're saying. It just comes across that way. Yeah. So for women as well, I think that we can work on presenting ourselves in a very confident way. Yeah. So hopefully that will also decrease sometimes the stigma that say people might have against female data scientists or female leaders, for example.